Good morning, students. Today we are going to discuss about this example. This is the final example, and also we will learn some problem set. Uh, First of all, in this example 12.5, the question is asked about to calculate the heat required. What is the heat required to convert 3 kg of ice, mass equal to how much? 3 kg of ice, initially at minus 12 degrees Celsius, ice at minus 12 degrees Celsius initially, kept in a calorimeter to steam at 100 degrees Celsius at atmospheric pressure. We need to find out the heat energy required to raise the temperature of ice from minus 12 to 0. At 0 degrees Celsius, it will change the state, and after that, the total ice will be in the form of water at 0 degrees Celsius. Still, we need to supply heat energy to the water at 0 degrees Celsius, so the temperature of water increases from 0 to 100. At 100 degrees Celsius, again, it will be converted into steam. That is, change of state occurs at 100 degrees Celsius at constant temperature. So, we need to find out this heat energy required to convert the heat from minus 12 degrees Celsius to steam at 100 degrees Celsius at given atmospheric pressure. So, the constant values are given. Given specific heat capacity of ice is to the 2100 joules per kg per Kelvin, and specific heat capacity of water we know is already 4186 joule per kg per Kelvin, and heat of fusion of ice is 3.35 into 10 to the power of 5 joules per kg, and latent heat of steam equal to 22.56 into 10 to the power of 5 joules per kg. We know this value already. Okay, so here, as we have discussed already about the graph of temperature versus heat, I am drawing it again. Temperature versus heat graph. Initially, it is in the form of ice at minus 12 degrees Celsius. When we supply some heat energy to the ice at minus 12 degrees Celsius, because of supply of heat energy, the temperature rises from minus 12 degrees Celsius to 0 degrees Celsius. Initially, the temperature is minus 12. The temperature rises from minus 12 to 0. At 0 degrees Celsius, when we keep on supplying the heat energy to the ice at 0 degrees Celsius, the ice will be converted into water slowly. So, the change of state occurs at 0 degrees Celsius. So, at constant temperature, the change of state occurs. The change of state from ice to water occurs at 0 degrees Celsius at constant temperature. So let us consider this is part 1. Heat energy required to raise the temperature from minus 12 to 0. And part 2, here we need to supply the heat energy in order to convert the ice at 0 degrees Celsius to water at 0 degrees Celsius. When the total ice get converted into water at 0 degrees Celsius, we keep on supplying the heat energy to the system. So temperature of water increases from 0 degrees Celsius to 100 degrees Celsius. This is the third part. The temperature increases from 0 to 100 degrees Celsius. At 100 degrees Celsius, if we keep on supplying heat energy at 100 degrees Celsius, the water at 100 degrees Celsius will get converted into steam at 100 degrees Celsius. This is fourth part. So, whenever the rise in temperature is there, so heat energy required is equal to delta Q equal to, simply we know the formula as ms delta T. And in the case of, this is in the case of rise in temperature. When rise in temperature occurs. Rise in temperature occurs from minus 12 to 0 and 0 to 100. So, this can be applied in first part and third part, 1 and 3 parts. this formula can be applied. And in the second step and fourth step, in second and fourth steps, that is there is no rise in temperature. What is happening here? At constant temperature, the change of state is occurring. That is solid to liquid and liquid to gaseous state. Change of state occurs at constant temperature. So in second and fourth parts, we use latent heat formula in this case. So as per this, the amount of heat energy required is equal to M into L, where M is nothing but amount of substance and L is a latent heat of respective change of state. Okay, so now I am applying for first part amount of heat energy required. Total amount of heat energy required is equal to amount of heat energy required in first part plus amount of heat energy required in second part plus amount of heat energy required in third part plus amount of heat energy required in fourth part. First part is to raise the temperature from whenever we supply heat energy to the ice at minus 12 degrees Celsius, the temperature rises from minus 12 degrees Celsius to 0 degrees Celsius. When there is a change in temperature, we apply this formula ms delta T. Change in temperature is there in this formula only. So here mass of the ice into specific heat of the ice into change in temperature is how much? Final temperature is 0 minus initial temperature is minus 12 for this case. Okay, right. Plus second step. This is for first step. And for second step, delta Q2. Delta Q2 is nothing but this is second step. In this second step, the change of state taking place. So in the case of change of state, we apply delta Q is nothing but simply M into L. So mass of the ice into latent heat of what is this? The change of state taking place from solid to liquid. So latent heat of fusion. So this is delta Q2. Okay, now I am taking this delta Q3. In third part, the amount of heat energy required is nothing but here temperature is increasing from 0 to 100 degrees Celsius. So the formula which is associated with change in temperature is nothing but again M, mass of the water, specific heat of the water, into delta T. Delta T is nothing but final temperature here is 100 minus initial temperature in this case is 0. Okay, this is for third case delta Q3. Now plus final part delta Q4 is nothing but in final part change of state is taking place at constant temperature. So we should use this formula for change of state. So mass of water into latent heat of steam. This formula is for delta Q4. So now I am substituting everything here. Now mass of the ice is 3 kg into specific heat of ice is nothing but 2100 joules per kg per Kelvin into 0 minus of minus is nothing but plus 12. So this is for first part plus mass of the ice is how much? 3 into latent heat of fusion is how much? Fusion of ice equal to 3.35 into 10 to the power of 5. Okay, plus and this part mass of the water is 3 kg and specific heat of water is nothing but 4186 joule per kg per Kelvin into 100 minus 0 is nothing but 100 again. So fourth part is mass of water is how much? 3 kg into latent heat of steam is nothing but 2.256 into 10 to the power of 6 joule per kg. That is, we can write it as 22.56 into 10 to the power of 5 joules per kg. So now by solving this, you will get the answer as it will be turned out as 9.1 into 10 to the power of 6 joules. So delta Q total. Solve this using a calculator. You will get the final answer. It will be turned out as 9.1 into 10 to the power of 6 joules. This is the amount of heat energy required in this case. Sorry. So this is the final answer. Right? Now I'm going to discuss a problem set. Wait a minute. I'm going to discuss 1 and 2 first. Okay. So here the first problem is about, yes, the first one is talking about what is the temperature for which the readings on Kelvin and Fahrenheit scales are same. Temperature of Kelvin is equal to temperature of Fahrenheit. In that case, what is the reading? Okay, so here I'm going to solve this one. We know the relation between Celsius scale and temperature Fahrenheit scale, that is Tc minus 0 by 100 is equal to Tf minus 32 by 180. We have proved this already. And also we know the relation between Kelvin scale and Celsius scale. Temperature in Kelvin equal to temperature in Celsius plus 273.15. So temperature in Celsius is equal to temperature in Kelvin minus 273.15. Substitute this Tc value here. So now wherever Tc is there, I am keeping Tk minus 273.15 divided by 100 is equal to Tf minus 32 divided by 180. So here the condition is given Tk is equal to Tf. Just wherever Tk is there, I am keeping Tf. So now Tf minus 273.15 divided by 100 is equal to Tf minus 32 by 180. So here the unknown thing is only Tf. So solve for this Tf. You will get Tf is equal to 574.6 degrees Fahrenheit or Kelvin. Both scales will show same reading at 574.6 degrees. Solve this, you will get this answer. Okay, now I am going to solve problem number 2. The problem number 2 is talking about find the increase in temperature of aluminum rod. Increase in temperature, that is change in temperature, is how much for aluminum rod if its length is to be increased by 1%. Fractional change in length, that is delta L by L, is given as 1%. Increase in length is 1%, that is nothing but 1 by 100. 1% is nothing but 1 by 100. And he has also given coefficient of linear expansion for aluminum. The coefficient of linear expansion for aluminum is 25 into 10 to the power of minus 6 per degree Celsius. Okay, so this is given. What is to be solved? We need to find out the change in temperature delta T. So I am writing like this. We know coefficient of linear expansion equal to delta L by L into delta T. So I am just rearranging the terms here. Delta T is equal to delta L by L into alpha. So here delta T is equal to delta L by L value is how much? Delta L by L is equal to 1 by 100. 1 by 100 into 1 by alpha. Alpha value is given, I as 25 into 10 to the power of minus 6. So shall I solve this? See here, 10 to the power of 2 and 10 to the power of minus 6 is there. So in the denominator, you will get 10 to the power of plus 4, minus 4. That is, I am writing it as 1 by 25 into 10 to the power of minus 4. So when 10 to the power of minus 4 comes to numerator, it will become 10 to the power of plus 4 divided by 25. So here I am writing delta T is equal to 10 to the power of plus 4 is nothing but 10,000 divided by 25. 25 4 ja 100, 0 is there. So delta T is equal to 400 Celsius degrees. 400 Celsius degrees is the answer for this question. So here is the answer. Now I am going to solve problem number 3. Here the problem number 3 is talking about, we solve problem number 3 and 4 here. Okay, first I am going to solve problem number 3. How much steam at 100 degrees Celsius is to be passed into the water of 100 grams at 20 degrees Celsius to raise its temperature by 5 degrees Celsius? How much steam? So what is the mass of the steam at 100 degrees Celsius? Initial steam at 100 degrees Celsius is passed into water of mass. Mass of the water is equal to how much? 100 grams. And initially it was at 20 degrees Celsius to raise its temperature by 5 degrees. So the change in temperature of water when the steam is added is equal to how much? 5 Celsius degrees. So latent heat of steam is 500 calories per grams and specific heat of water is 1 calorie per gram. Here the latent heat and specific heat is given in terms of calories, not in terms of joules. So here whenever this steam is added to water, steam is losing the heat energy and water is gaining the heat energy. So there are two parts. Once the steam, so here in this case the temperature raised from 20 degrees Celsius to 25 degrees Celsius. Temperature of water changes from 20 degrees Celsius to 25 degrees Celsius. So the equilibrium temperature is 25 degrees Celsius. So when the steam is passed into the water, heat lost by steam is equal to heat gained by water. So when this steam is there at 100 degrees Celsius, first steam get converted into water at 100 degrees Celsius at constant temperature. So amount of heat energy to change the state from from gaseous state to liquid state plus, so now the water is at 100 degrees Celsius. So that water, when total steam is get converted into water, now water is at 100 degrees Celsius. Again that water reaches the temperature of 25 degrees Celsius. So heat lost by water at 100 degrees Celsius whenever the temperature decreases from 100 degrees Celsius to 25 degrees Celsius. The amount of heat energy lost equal to how much? MS delta T. So here I am writing this heat energy lost by water at 100 degrees Celsius whenever its temperature changes from 100 degrees Celsius to 25 degrees Celsius. So this is the heat lost by steam. So heat lost is always indicated with negative sign, which is equal to heat gained by water initially at 20 degrees Celsius. Heat gained by water is nothing but, we know delta Q. This water is different, which is initially at 20 degrees Celsius and raises its temperature by 5 degrees Celsius. That means the temperature raises to 25 degrees Celsius. So heat energy gained by water at 26 water from 20 degrees Celsius to 25 degrees Celsius. This is the water which is initially at 20 degrees Celsius. Its temperature rises by 5 degrees Celsius. That means the temperature increases to 25 degrees Celsius. So now the formula is whenever the gaseous state is to change the state from gaseous to liquid, we apply M into L, mass of the steam, into latent heat of steam, plus mass of the steam, we don't know, into specific heat capacity. Whenever the temperature is changing, we apply ms delta T formula. Here mass of the steam or mass of the water into specific heat of water into change in temperature, which is equal to mass of the initial water and specific heat of water into change in temperature. Okay, so minus, we don't know mass of the steam here. I'm taking mass of the steam as constant. So wait a minute. Mass of the steam into what is there? Ls. Ls value is given as how much? Ls is equal to latent heat of steam equal to 540 calories per gram. 540 calories per gram plus ms is taken out as common. Specific heat of water. Specific heat of water is how much? 1 calorie per gram per Celsius. 1 calorie per gram per Celsius into change in temperature. Temperature decreases from 100 to 25. So final temperature is 25 minus initial temperature is 100 Celsius degrees. So here Celsius and Celsius get cancels, which is equal to mass of the water is given. He has given the mass of the water as 100 grams into specific heat of water is nothing but 1 calorie per gram per degree Celsius into change in temperature. Temperature changes from 20 to 25 degrees Celsius here. So final is 25 minus initial is 20 Celsius degrees. So here Celsius and Celsius get cancels. So grams and grams also get cancelled here. So minus ms into 540 is there, calories per gram, 25 minus 100. 25 minus 100 is nothing but minus 75. 540 minus 75 is nothing but 540 minus 75 is equal to 100 into 5. 100 into 5, 500 calories. Here 500 calories per gram minus 75 calories per gram. Calories per gram is there. So here calories and calories get cancels. So now Now 540 minus 75. Solve on this, you will get the answer for ms by using calculator. Sorry, here this negative sign is only for heat lost. So you will get only for negative sign is only here minus. So minus of minus plus. So 500 divided by 540 plus 75 is how much? 615 grams. So you will get the answer by solving this. Okay, now I'm going to explain about problem number 4 here. The problem number 4 is 2 kg of air is heated at constant volume volume is kept constant. The mass of the air is equal to how much? Mass is equal to 2 kg, and the temperature of air is increased from 293 Kelvin to 313 Kelvin. So change in temperature equal to 313 Kelvin minus 293 Kelvin, which is equal to 20 Kelvin, right? Next, if the specific heat of air at constant volume is 0.718 kilojoules per kg per Kelvin, specific heat of air is equal to 0.718 kilojoules per kilogram into Kelvin per Kelvin. So he asked to find the amount of heat absorbed in kilojoules as well as in kilocalories. So heat absorbed, delta Q is equal to, simply here the temperature is changing, so we apply ms delta T formula. So what is mass here? 2 kg into specific heat capacity is how much? Here the mass is how much? 2 kg into specific heat capacity of air is 0.718 kilojoules per kilograms into Kelvin per Kelvin into delta T is how much? Here delta T is equal to 20 Kelvin. So here Kelvins and Kelvins cancels, kilograms and kilograms get cancels. You will get the answer in kilojoules only. So now multiply the given values in the equation. 2 into 0.718 into 20. You will get it as 28.72 kilojoules. And he has given that he has asked to convert into kilocalories also. Kilocalories. So here 1 joule is equal to 4.2 kilojoules per kilocalories. Okay. So we know 1 calorie is equal to 4.2 joules. Multiply both sides with kilo. Okay. So 1 kilocalorie is equal to 4.2 kilojoules. So convert this one now. So the amount of heat energy required is equal to how much? 28.72 kilojoules into 1. I can write like this. So here from this 1 kilocalorie per 4.2 kilojoules is equal to 1. I am replacing 1 with this value. So delta Q is equal to simply 28.72 kilojoules into, I am keeping 1. 1 kilocalorie is nothing but 4.2 kilojoules. Okay. Now here kilojoules and kilojoules get cancels. You will get the delta Q value as 28.72 divided by 4.2 into what is there? Leftover is kilocalories. You will get the answer in kilocalories now. Now I am going to explain problem number 5 and 6. Now I am going to explain a clock with a brass pendulum keeps correct time at 20 degrees Celsius but loses 8.212 seconds per day. Okay. Time period of simple pendulum is nothing but 2 pi root L by G. And by squaring on both sides, we will get T square equal to 4 pi square into L by G. So here L is directly proportional to T square. Okay. Per day, how many? In one day, how many seconds are there? We have 24 hours. That is 24. 1 hour is nothing but 60 minutes. So 24 into 60 into 1 minute is nothing but 60 seconds. By solving this, you will get 86,400 seconds. 86,400 seconds in a day. So in a day, out of 86,400 seconds in a day, it loses 8.212 seconds per day when the temperature rises to 30 degrees Celsius. When this is nothing but time period, not temperature. So when temperature change is equal to 30 degrees Celsius minus 20 degrees Celsius, which is 10 Celsius degrees, when temperature changes to 10 Celsius, temperature changes by 10 Celsius degrees, what is the coefficient of linear expansion of brass? So here we know the formula as L is directly proportional to time period, square of the time period. So L1 by L2 is equal to, so here L2 minus L1 by L1 is equal to, L2 can be written as T2 square minus L1 is nothing but, L1 is directly proportional to what? T square, T1 square. So T2 square minus T1 square divided by L. L is proportional to L1, initial length L1 is T1 square. So A square, it is the form of A square minus B square, that is T2 minus T1 change in time periods divided by T1 square. A square minus B square can be written as A minus B into A plus B, T2 minus T1, T2 plus T1. Okay, so we can for one day the decrease in time is 8 seconds. So for one time period, for one oscillation, the decrease in time is how much? 8.212 divided by 86,400, which is very, very small in comparison. So I can write T1 plus T2 as 2T1. Therefore, T2 minus T1 time period, change in time period, into T1 plus T2 can be written as 2T1 by T1 square. So here T1 and 1T1 get cancels. So this is nothing but change in time period. The change in time period is how much? So it is equal to 8.212 by, per day is equal to 8.212 divided by 86,400 into 2 by T1 into 2 by T1. So this change in time period with original time is nothing but, original time is how much? 8.212 by 86,400. This value is nothing but, this is nothing but change in time period per day. So T2 minus T1 by T1 equal to 8.212 by 86,400. So this total value is nothing but T2 minus T1 by T1 equal to 8.212 by 86,400. What is remaining here? Into 2. So this is nothing but L2 minus L1 by L1. So now we know alpha equal to L2 minus L1 by L1 into T2 minus T1, change in temperature. So L2 minus L1 by L1 value is how much? 8.212 by 86,400 into 2 into 1 by T2 minus T1. So 1 by change in temperature is how much? 10. By solving this, you will get the answer for alpha. Okay. Now I am going to explain problem number 6. Here the problem number 6 is a body cools from 60 degrees Celsius to 40 degrees Celsius in 7 minutes. What will be its temperature after next 7 minutes if the temperature of its surroundings is equal to 10 degrees Celsius. So here here temperature of surroundings. Temperature of surroundings T1 is equal to how much? 10 degrees Celsius. And average temperature of the body. Average temperature of the body T2 is equal to 60 plus 40 by 2. Average temperature is 60 plus 40 by 2, that is nothing but 50 degrees Celsius. And change in temperature of body, change in temperature of body is equal to dT2. Change in temperature of the body is nothing but 60 minus 40. 60 minus 40. Change in temperature of the body is 60 minus 40. That is nothing but simply 60 minus 40, which is equal to minus 20 degrees Celsius. So now we know the formula as we solved for example is nothing but dT2 by T2 minus T1 is equal to some constant K into time interval. So dT2 is how much? Minus 20. Minus 20 divided by T2 minus T1. Average value of T2 is how much? 50 minus T1 is 10 is equal to some constant into dt. What is the time taken here? Yes, given that in first 7 minutes. So let this value is 7 minutes. Let it be equation number 1. So now what is asking, what will be its temperature after next 7 minutes? Next 7 minutes, after next 7 minutes. So in next 7 minutes, let T2 average temperature T2 is equal to 40 plus T divided by 2. 40 plus T divided by 2. And dt value is equal to how much? 7 minutes. Now again from the same formula, dt2 divided by T2 minus T1 is equal to some K into dt. So dt2 is nothing but change in temperature of the body. Final temperature, let we consider it as a T. So dt2 is nothing but 40 minus T divided by T2 minus T1. T2 average temperature of body is equal to how much? 40 plus T divided by 2 minus T1 is nothing but 10 is equal to some K into dt. dt is nothing but 7 minutes again. Let this is equation number 2. So from equation number 1 and 2, equation number 1 and 2, so 20 divided by 50 minus 10 is nothing but 40 divided by, I am doing 1 by 2, equation 1 by 2. So 20 by 40 is nothing but 40 minus T by 40 plus T divided by 2 minus 10 is equal to some K into 7 minutes by K into 7 minutes. K into 7 minutes by K into 7 minutes. So this and this cancels, you will get 1 here. So 20 by 40 is nothing but 1 by 2. Okay. So 20 by 40 is nothing but 1 by 2 is equal to 40 minus T divided by 40 plus T divided by 2 minus 10. So on cross multiplying you will get 40 plus T by 2 1 second, minus 10 is equal to 2 into 40 minus t. So I am solving this. 40 by 2 plus t by 2 minus 10 is equal to 2 into 40 is nothing but 80 minus 2t. Okay, 40 by 2 is nothing but 20. 20 minus 10 is 10. So t by 2, 10 plus t by 2 is equal to 80 minus 2t. So I am rearranging the terms. 2t plus t by 2 is equal to 80 minus 10. 80 minus 10. So 2 into 2 is nothing but 40 plus t. 5t by 2 is equal to 70. So 5t is equal to 140. So t is equal to 140 by 5. So t is equal to 2 ja 4 2 8 ja. So 28 degree Celsius. The final temperature after 7 more minutes equal to 28 degrees Celsius. See here, from this example, we can conclude that in first 7 minutes, initially the body is at 60 degrees Celsius. The temperature falls from 20 degrees Celsius to 40 degrees Celsius in first 7 minutes. And in next 7 minutes, the temperature falls from 40 degrees Celsius to 28 degrees Celsius only in next 7 minutes. So if the temperature of the body is so high, the change in temperature in this case is how much? 20 degrees Celsius. 60 minus 40 is nothing but 20. In the next 7 minutes, what is the change in temperature? 40 minus 28, 12 Celsius degrees only. So if the temperature of the body is more, the rate of cooling is also will be more. So you should not leave the hot water alone. You should not leave the boiling water alone if you want to go for a bath after 15 or 20 minutes. What should you do? In order to avoid the fast cooling down, you should add some cold water so that the temperature drops. If the temperature of the initial temperature of the body is less, so rate of cooling is also less. So that's why you should add some cold water to hot water if you take some amount of time to get bath. Thank you. This is the conclusion. You in same time interval. In first time interval, if the temperature of hot body is equal to 60 degrees Celsius, it loses 20 degrees Celsius in first 7 minutes. In next 7 minutes, and the initial temperature is 40 and final is 20. That means if the temperature of the body is less, it loses less amount of heat energy. So in next 7 minutes, it loses only 12 degrees Celsius. So it is better to add cold water to boiling water in order to take time. Thank you. Have a nice day, students. Bye-bye.